we're going to look at transformations of functions. So this is all of the shortcuts on how to graph. All right, so if we have this function, f of x is the square root of x. So we just take the square root of our input. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Now let's look what happens. Here, I'll just graph that really fast. Let's see, 1, 1, and 4, 2. All right, so there's our parent function of a square root. Now, if what we do is after we deal with our input and then we add 2 at the end, what we're doing is we're impacting the output. It's going to slide the graph up. So let me show you what happens. I square root my 0, and then at the end I add 2. I square root my 1, at the end I add 2. Square root my 4, at the end I add 2. So what happens is all these points just slide up. What was originally at 0, 0 is now slid up to 0, 2. What was at 1, 1 has slid up, and what was at 4, 2 has also slid up. So the whole graph just moved up. Okay, now on this next one, we're subtracting 2, and our whole graph is just going to move down. So what used to be at 0, 0 is just going to move down. What used to be at 1, 1 is going to scoot down. What used to be at 4, 2 is going to scoot down. So this is going to be our new function. And I'll show you that because, right, we take that original input, square it, and subtract 2. Square 1, subtract 2. Square 4, subtract 2. All right, so that is what impacts our graph moving up or down. Those are called vertical shifts. Okay, moving on, let's look at a horizontal shift. This happens when you go in and you mess with the input. Okay, so if I have my original parent function as absolute value. All right, so our original parent graph, we've got 0, 0, and 2, 2. All right, so it just is absolute value of that input. All right, now if we go in and subtract 2 from 0, we'd get -2, but absolute value of -2 is 2. 2 minus 2 is 0. Absolute value of that is 0. -2 minus 2, that's -4. Absolute value of that is 4. 3 minus 2, that is 1. -3 minus 2 is -5. Absolute value of that is 5. So let's go ahead and graph those. So here's the parent graph. There's our nice V for absolute value. All right, and now here we have, this is the same one. It's just everything is slid over. Let's see, we're at 3, 1, and -3, 5. Okay, so when you subtract a number, it slides your graph to the right. All right, and now if we add a number, what it's going to do is slide it to the left, but we'll go in and look at that. All right, 0 plus 2, that would be absolute value of 2, which is 2. 2 plus 2 is 4, absolute value of that is 4. -2 plus 2 is 0. 3 plus 2, that would be 5, and -3 plus 2 is -1, but absolute value of that would be 1. Okay, so here we have our 2, 4, our function. Okay, so when you add a number, it slides left. And when you do the opposite of a function, it reflects it about the x-axis. And then when you do the opposite of the input, that reflects it about the y-axis. So that was the symmetry we did a couple seconds ago. Okay, so here's our parent graph of square root of x. And then when you do the opposite of the input, it would allow you to take the square root of the opposite of -1, which is 1. So that's defined. The opposite of -4, we can take the square root of 4. So that just reflects that across the y-axis. Okay, now when we have a coefficient in front of our function, if we're multiplying everything by 2, it's just going to make, excuse me, it's going to stretch everything taller. So we'd still start at the same place, but now we're up where our output is just higher. Okay, and then if we shrink it, it would just shrink that input, or sorry, the output. So we would, instead of being at 1, we'd be at 1/2. Instead of being at 2, we'd be at 1. So it's just a shallower little hillside here. And then we can do horizontal stretching and shrinking if we go in there and change the input. So here's our parent graph for absolute value. All right, so with the horizontal shift, if there's a coefficient in being multiplied by the input, what happens is we're going to get to, just like we got up to 2 right here, it's just that it's going to not take us so long to get there. It's just going to take us an input of 1 to get all the way up to an output of 2. So it just shrinks that horizontally. Okay, let's see here. It's going to take longer for us to get to 2 on this. So we got to 1, but in this case, it's going to take us 2 units over for the x to get up to 1. So we'd just be at 1/2. So that's a horizontal stretch. Those are at 1/2. All right, so I'm going to just give you a little bit of time to think through this. So I want you to just describe what's going to happen to our graph. What are the transformations that happen? So pause the video and see what you can come up with. All right, so there's those first ones. My hint is on this one, think of that like a -2, and then 2 times my function, and then we're adding 3. All right, so there's 3 things that happen. First, we have our vertical stretch, and then we're reflecting about the x-axis, and then we're adding 3 at the end. So that shifts our graph up by 3 units. And I know we can just pull out our, online calculator, Desmos, or a graphing calculator and be able to look at these, but it is nice just to be able to really quickly just know what the graph is going to look like. It's going to help us as we move on in calculus as well. Okay, so let's put these together and just go ahead and, without pulling out your calculator, see if you can come up with what these are going to look like. Okay, so first the parent graph. Done. Okay, next the first transformation I'm going to do is I am going to shift it because of this adding 4. Think in your head, what way do we shift? So that shifts it left 4 units. Okay, good. And now we're going to subtract 3 from the output. So we have, that was an x. We're going to subtract 3 at the end, so that just slides everything down 3. So now we're at -4, 1, 2, 3. All right, there we go, done. Okay, let's do some more. Okay, so we have our parent function, absolute value. Go ahead and sketch that. Okay, and now we're going to do the reflection about the x-axis. Okay, so there's that one. And okay, then the final one is where we are adding this 2. There's no negative in front of the 2, so that is an adding 2. So that would be the same thing as if we had the opposite of absolute value of x plus 2. It's just written kind of out of order. Okay, so we'll shift graph up 2 units. So everything just moves up. All of our points move up 2 units. So we're here, here, here. Oopsie. That should be there. All right. There we go. All right, let's do our next one. Okay, so parent function. That's just our y equals x squared. So go ahead and graph that. And then let's do our first one is let's subtract 1 from the input. All right, so go ahead and pause. I'll give you a minute to sketch out your graph. And I'm hoping that's really quick, right? Because you're just taking your input and squaring it. So 1 squared is 1, 2 squared, we should be up at 4. Okay, so that first structure is super straightforward, and then this is that reflection across the y-axis for the squared, for the graph of y equals x squared. Okay, now we're subtracting a number from our input. Is that a horizontal or a vertical slide? You're right, it should be, well, hopefully you thought of this, hopefully you are thinking it's a horizontal. We're going in there and we're messing with the input, and the input is the x's, okay? So when we subtract, we slide right. Let's see, and 4. Okay, so there's that one. Horizontal shift to the right. Okay, this next one I'm just going to think of this as -1 times. So I'm going to do a stretch by multiplying by 2. So everything will just get stretched up. We're still at 0, 1, but now instead of only going up 1, we're going up 2. Instead of coming up just to, let's see, this was at 2, 1, so this went up now, stretched up to 2, 2. This one was at 3, 4, but now we're doubling our output, so that should be at 3, 8. So that's up here at 3, 8. There we go. Okay, good. Now we need to deal with that -1, and then we'll deal with the 3. I'll make that so we can still see it. Okay, so I'm still going to have that point at 1, 0, but now this point I'm going to just make my output negative. So instead of 2, 2, it would be 2, -2. Okay, so there's that. For when we took y and we did the -1 times 2x minus 1 quantity squared. Whoops, not there. And now we need to add 3. So we'll just slide everything up. 1, 2, 3. Everything goes up 1, 2, 3. Up 1, 2, 3. Okay, so go ahead and graph that and we'll be done. All right, so then we just shift that graph up 3 units. All right, so we've done a lot. Just one more thing is to talk about even and odd functions. So it's just another way of talking about whether things are symmetric about the y-axis. So to be symmetric about the y-axis, that is when you can go in and take the opposite of your input and come out with the exact same graph. And then odd, those are the ones that are symmetric about the origin. And that's when you put the opposite of your input and it makes it the opposite of the actual function itself. So let's do an example. Okay, so if I'm trying to graph this, it's helpful to think about symmetry. So I'm just going to double check, is this even? Okay, and that's all I have to do is just do the opposite of my input, plug that in, and just see what happens. Okay, cubing a negative makes the whole thing negative, and then negative times negative would make it plus 3x, which is not the same as my original function, so this is not even. Okay, let's see if it's odd. Let's see. On these ones, we check to see if the opposite of the input makes the opposite of the function itself. Okay, so when we did the opposite of our input, what we got out was negative x cubed plus 3x, and that is the same as taking a negative 1 times x cubed minus 3x. So that's the same thing as the opposite of the function itself. So yes, this is odd. All right, now we're supposed to graph. Okay, so we just need to get a few points and use that symmetry. So I'm just going to do some points here. Okay, and usually we'd have to do all 5, but because we know that symmetry, we can just do a couple points. So I'm just going to do 0, 0 cubed minus 3 times 0, that's 0. Here this would be 1 cubed minus 3 times 1, so that is negative 2. Okay, now this is symmetric about the origin, so I'm going to have the same point reflected through the origin right here. Okay, so I'm using that symmetry. This one is going to be at positive 2. And let's see, this would be 2 cubed, which is 8 minus 3 times 2. So this is 2. And this one would be opposite of that, negative 2, negative 2. Okay, so this function goes up, comes down, and back up. There's our graph. So I do want to encourage you just to play around with these and try these next 2 problems on your own. Go ahead and pause, and then I'll show you the answers.